supporting metal-clad cable with sealing wire requires that the sealing wire is securely attached to the sealing structure and rated to support the weight of the cable and any attached devices. A freely dangling sealing wire is not suitable for supporting metal-clad cable. Similarly, supporting conduit with sealing wire necessitates a secure attachment point on the sealing capable of bearing the weight of the conduit and any conductors within. A freely dangling wire is insufficient for this purpose. Several additional considerations apply to both metal-clad cable and conduit installations. Firstly, the sealing wire installation must adhere to all relevant building codes and electrical safety standards. Secondly, the correct size and type of sealing wire must be selected based on the anticipated load. Thirdly, any signs of damage or deterioration in the sealing wire necessitate immediate replacement before any cable or conduit installation. Furthermore, it is always advisable to have a qualified electrician inspect and approve the installation prior to energizing the circuit. Building codes and electrical safety standards mandate specific requirements for supporting electrical cables and conduits. These regulations are in place to ensure the safety and longevity of electrical systems, preventing hazards such as sagging wires, damaged insulation, and potential fire risks. The National Electrical Code, or NEC, provides detailed guidelines on proper support methods, spacing intervals, and acceptable materials. Understanding these requirements is crucial for ensuring compliance and preventing code violations. When selecting sealing wire for supporting metal-clad cable or conduit, it is essential to consider the weight of the materials involved. Metal-clad cable consists of insulated conductors encased in a metallic sheath, which adds considerable weight compared to non-metallic cable. Conduit, whether rigid metal conduit, intermediate metal conduit, or electrical metallic tubing, also contributes significantly to the overall load. The sealing wire must be rated to support this weight, along with any additional devices or fixtures that may be attached to the wiring system. The attachment point of the sealing wire to the sealing structure is equally important. A secure and reliable connection is necessary to prevent the wire from pulling loose under load. This may involve using appropriate fasteners, such as screws, bolts, or anchors, depending on the type of sealing material. The attachment point should be capable of withstanding the combined weight of the cable or conduit, the sealing wire itself, and any additional stress caused by vibration or movement. Freely dangling sealing wire lacks the necessary support and stability to safely carry electrical cables or conduits. The absence of a fixed attachment point means that the wire is prone to swaying and shifting, which can damage the cable or conduit, loosen connections, and create a safety hazard. In addition, a dangling wire provides no protection against accidental contact, which could result in electric shock or injury. Regular inspection of sealing wire installations is essential to identify any signs of damage or deterioration. Over time, sealing wire can weaken due to corrosion, stress, or physical damage. Signs of corrosion include rust, discoloration, and flaking. Stress can cause the wire to stretch or sag, reducing its load-bearing capacity. Physical damage, such as cuts, kinks, or abrasions, can compromise the wire's integrity. Any of these conditions warrant immediate replacement of the affected sealing wire. A qualified electrician possesses the knowledge, skills, and experience to ensure that electrical installations are performed safely and in compliance with applicable codes and standards. An electrician can assess the existing wiring system, determine the appropriate support methods, and install the necessary components correctly. They can also identify potential hazards and recommend solutions to mitigate risks. Consulting with an electrician before undertaking any electrical work is always a wise decision. The National Electrical Code, specifically Article 300.11, addresses securing and supporting wiring and cables. This section emphasizes the importance of providing adequate support to prevent damage to conductors, insulation, and terminations. It also outlines acceptable methods for securing wiring to building structures, including the use of straps, staples, cable ties, and hangers. For metal-clad cable, the NEC typically requires that it be supported at intervals not exceeding 6 feet, with additional support within 12 inches of boxes, cabinets, and fittings. The specific requirements may vary depending on the size and type of cable, as well as environmental conditions. Conduit installations also have specific support requirements outlined in the NEC. The support intervals for conduit depend on the type and size of conduit, as well as the spacing between supports. For example, rigid metal conduit typically requires supports at intervals not exceeding 10 feet, while electrical metallic tubing may require supports at intervals not exceeding 5 feet. In addition to support intervals, the NEC also addresses the methods used to secure conduit to building structures. Acceptable methods include the use of conduit clamps, straps, and hangers, which must be properly sized and installed to provide adequate support. When installing sealing wire to support metal-clad cable or conduit, it is crucial to select the appropriate size and type of wire. The wire gauge, which indicates the wire's diameter, is a key factor in determining its load-bearing capacity. Thicker wires have a higher load-bearing capacity than thinner wires. The type of wire, such as steel or galvanized steel, also affects its strength and durability. Steel wire is generally stronger than galvanized steel wire, but galvanized steel wire offers better corrosion resistance. The weight of the metal-clad cable or conduit, the support intervals, and any additional loads must be considered when selecting the appropriate size and type of sealing wire. It is also important to consult with a qualified electrician or engineer to ensure that the selected wire is suitable for the intended application. The installation of sealing wire should be performed with care and attention to detail. The wire should be securely attached to the sealing structure using appropriate fasteners, such as screws, bolts, or anchors. The fasteners should be sized and installed to provide adequate holding power, taking into account the weight of the cable or conduit and any additional loads. The wire should be routed in a manner that minimizes stress and strain, avoiding sharp bends or kinks. The wire should also be protected from abrasion or damage, especially in areas where it may come into contact with other objects. Regular inspections of sealing wire installations are essential to identify any signs of damage or deterioration. The inspection should include a visual examination of the wire, the fasteners, and the attachment points. Any signs of corrosion, stress, or physical damage should be addressed immediately. Corrosive fasteners should be replaced, stressed wires should be retensioned or replaced, and damaged wires should be replaced. The frequency of inspections depends on the environmental conditions and the severity of the loads. In harsh environments, such as those with high humidity or corrosive chemicals, inspections may be required more frequently. It is also important to inspect sealing wire installations after any significant events, such as earthquakes or storms, to ensure that they have not been damaged. Building codes and electrical safety standards are constantly evolving to reflect new technologies and best practices. It is essential to stay up to date on the latest requirements to ensure compliance and prevent code violations. This may involve attending training courses, reading industry publications, or consulting with a qualified electrician or engineer. The National Electrical Code is updated every 3 years, and it is important to be aware of any changes that may affect sealing wire installations. Local building codes may also have specific requirements that must be followed. In addition to complying with codes and standards, it is also important to follow best practices when installing sealing wire. This includes using high-quality materials, employing proper installation techniques, and performing regular inspections. By following best practices, you can ensure that sealing wire installations are safe, reliable, and long-lasting. The use of non-metallic cable ties, also known as zip ties, for supporting metal-clad cable or conduit is generally not recommended. While cable ties can be useful for bundling and organizing wires, they lack the strength and durability required to provide adequate support for heavy cables or conduits. Over time, cable ties can degrade due to exposure to sunlight, heat, and chemicals, which can cause them to break or loosen. This can lead to sagging wires, damaged insulation, and potential safety hazards. Instead of cable ties, it is recommended to use approved support methods such as straps, staples, or hangers, which are specifically designed for supporting electrical cables and conduits. These support methods provide a more secure and reliable connection, ensuring that the wiring system is properly supported and protected. When working with electrical systems, it is essential to prioritize safety. Always disconnect power before working on any electrical components, and use appropriate personal protective equipment, such as gloves, safety glasses, and insulated tools. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Before beginning any electrical work, it is important to obtain the necessary permits and approvals from local authorities. This ensures that the work is performed in compliance with applicable codes and standards, and that it is inspected by qualified professionals. Obtaining permits and approvals can also help to protect you from liability in the event of an accident or injury. The permit process typically involves submitting plans and specifications for the proposed work, paying a fee, and scheduling an inspection. The inspection is conducted to verify that the work has been performed in accordance with the approved plans and specifications, and that it meets all applicable codes and standards. In conclusion, supporting metal-clad cable and conduit with sealing wire requires careful planning, proper installation techniques, and adherence to applicable codes and standards. The sealing wire must be securely attached to the sealing structure, rated to support the weight of the cable or conduit, and inspected regularly for signs of damage or deterioration. A freely dangling sealing wire is not suitable for supporting electrical cables or conduits. By following these guidelines, you can ensure that electrical installations are safe, reliable, and compliant with all applicable regulations. The use of J-hooks is also a suitable alternative to sealing wire for supporting cable and conduit. J-hooks are specifically designed for supporting cables and conduits, offering a secure and organized solution. They are easy to install and provide a clean, professional look. Always make sure the J-hooks are also rated for the specific load that they are intended to support. They come in various sizes and materials to accommodate different cable and conduit types and sizes. When using J-hooks, ensure they are spaced properly according to the NEC requirements to prevent sagging or damage to the cables or conduits. Regular inspections are still necessary when using J-hooks to check for any signs of wear or damage and to ensure they continue to provide adequate support. By choosing the appropriate support method and following best practices, you can create a safe and reliable electrical system that meets all applicable codes and standards.